right, hey guys, happy Friday. Remember today is the last day of the marking period, so if you need to contact me or Mr. Q, please do it like now. All right, so quadratic word problems. So here we got the product of two consecutive odd numbers, right? So anytime I've got an x, right? Like let's say x is the number 5, then the next consecutive number would be 5 plus 2 or 7, right? So these are my consecutive odd numbers. Okay, they are also factors, right? So this product right here means to multiply. And factors are any terms that multiply to give you whatever your answer to that is, right? So these guys right here are factors of this guy, of 783. Okay, so I've got one factor, and then in parentheses, that's your second factor. X plus 2 is your second. All right, so you have to go in and look for mistakes. Well, if they are doing quadratic formula here, then I absolutely love that they subtracted 783 on both sides. That probably didn't help. But that they subtracted that. You see it right here, right? 783 minus 783 is 0. And then if you move that to the other side, it gives you a negative 783. Okay, so if you're going to do quadratic formula, you gotta have it equal to 0. Otherwise, your A, which is 1, right, that invisible 1, your B, which is 2, and importantly here, your C, which is not a positive 783, but a negative 783. So it's super important, guys, that you have it equal to 0. Otherwise, the sign of either your A, your B, or your C is going to be wrong. Okay? They all have to be on the same side in order for your A, B, and C values to be correct. Cool. So your the mistakes here were that there should not be a negative 2, right? This is a positive 2. And here, this is a negative 783, so that should be negative 783. Okay. Okay, so all of this math for the discriminant does give you 3136, right? So you can put all of this discriminant right here in your calculator, and it will give you 3136. All right, so that positive discriminant tells me I'll have two answers for x, and I do. I have x equals 27, and I have x equals a negative 29. So what are we talking about? We're talking about ages. So can an age be 27? Can you be 27 years old? So yeah, that works. Can you be negative 29? No. So this, even though negative 29 is mathematically a solution and it's absolutely correct, it cannot be a solution for this problem because it's just not an age. So I know that one of my ages is 27 years old. And the next consecutive number after that is 27 plus 2, which is 29. So those are two odd numbers that go back to back. That's what consecutive means, right? 27, 29, the next one would be 31, 33, right? And so on. But these two consecutive ages, their product, and check it in your calculator, should be 783. And it is. If it gave you a different answer than that, right? Like if you used both of these and it gave you negative 783, that would be a hint, hey, I did something a little wrong. Okay, so now we are diving deep into those word problems. So you have a rectangular soccer field. So I'm actually going to draw it over in my variable section. So I've got a rectangular field. Let me just use this whole thing as my rectangular field. Okay. And the area is 3,700 square yards. So areas always go inside. And the way I write square yards is yard and then the squared symbol. Cool. All right. So the soccer field must be 24 yards longer than its width. So if the width is the shorter of the two sides, the length would have to be W plus 24, right? So this is 24 yards longer, right? 24 yards longer, specifically compared to its width. All right. So again, what's on the outside are your factors. So my equation would be W, right? This factor times my other factor of W plus 24. And those two factors, when I multiply them, that will give me 3,700. All right. So now my solution, I can do complete the square. I can do factoring, right? Quadratic formula. So I don't know what I want to do yet. Let me see. W times W is W squared. W times 24 is 24W. Oops. 24W. I said it. I just didn't write it. Okay. And I actually feel like I'm going to do complete the square because I already have the W term and the W squared term by itself. What I need to do now is if I want to complete the square, I need to make a square. So here's my square. And again, the first term always goes in this first box over here. And then this W term is going to get split evenly into these two boxes. So I've got a positive 24W. So that gets split evenly 12W and another 12W. So 12 plus 12 is 24. All right, so now let me figure out those factors and what I need to complete this square. So W times W is W squared. W times 12 is 12W. And the same thing, remember it's a square, it's got to be the same thing, right? W times 12 is this other 12W. Cool. All right, now I need to actually complete this square. Okay, so 12 times 12 is 144. All right, so I'm going to be adding 144 to both sides. I add it to this side, 24W plus 144. I add it to that side to make this whole thing a perfect square trinomial. And I got to add it to this side, and I'm just going to put it underneath because I don't have room. I add it to that side just to keep it balanced. Remember the equal sign. What you do to one side, got to do to the other side. All right, so I'm going to erase my beautiful square over here. Just remember to copy it down and that this is what we added to both sides. It wasn't in my original equation. It's what I had to add to get a perfect square trinomial going. All right, so I'm going to erase that beautiful work. Okay, and I'm just going to rewrite this over here. So W squared plus 24W plus 144 equals, and now 3,700 plus 144 is 3,844. Okay, cool. All right, so if you happen to have done this with a different method, that's fine. Just follow along and make sure that you get the right answer. All right, so W squared plus 24W plus 144. Remember, this is my perfect square trinomial. Oops. All right, that's my perfect square. So I can rewrite that as W plus 12. Hopefully you still have that square written down, or you remember it, squared equals 3844. All right, so now I'm going to do the square root to both sides, not forgetting my plus minus, and I'm actually going to use my calculator. All right, but first, square and square root cancel out, so I get W plus 12 equals a positive and a negative. Let's see, what number are we going to get? So square root 3844. Oh, and it's an even 62. So remember, it's not just 62, it's 62 and negative 62. All right, so let me just subtract 12 on both sides. All right, so positive 62 minus 12 is a positive 50. And negative 62 minus 12 is a negative 74. Okay. And are these, yeah, these are in yards. So this would be negative 74 yards and 50 yards. Okay. All right. So we're talking about lengths and widths. So can I have a width of 50 yards? Yeah, I can, right? Okay. Can I have a width of negative 74 yards? No, I cannot, even though mathematically it's cool, right? It actually doesn't exist in real life. So my width here is 50 yards, but remember, my length is 24 yards longer than that. So if my width is 50 yards, my length would be 24 yards more than that, right? So 50 plus 24, 74 yards, right? So that's my length. And the W is my width. Okay, so those are my answers. Don't forget the units, right? If they ask for it, then you need to have those units there. Okay. So situation B. So a rectangular picture measures 6 inches by 8 inches. All right, so let me just draw that here. So 6 by 8, okay. And now Simon wants to build a wooden frame for the picture so that the framed picture takes up a maximum area of 24 square inches on his wall. So if they ask you for a frame, or sometimes it's a garden problem and they want a path around the garden, then I just need to draw another rectangle around my original one. So what I did on black, that's a 6 by 8 rectangle. What I did in red, it's going to be bigger than that, right? I just don't know how much. All right, so the framed picture takes up a maximum area of 24 square inches. So I'm going to keep it in red because this 24 squared inches is how long the bigger, the outer rectangle that includes the black rectangle, right? So the 24 square inches is that whole thing. Okay, now this is super important. So he wants to use a frame or build a frame that all have the same width. So let's call that width W. Cool. So that just means if I have like a W here, right, that this width is that variable. Okay. So if I'm going to use W there, then this width is W. This width is W. And this width is also W. Okay, so from wherever the black ends to where the red is, that length is all going to be the same. So if you put X for all of them, great. But if you put W for all of them. Alrighty. So I'm going to just redraw just the red rectangle over here. Or maybe it would be easier if I did it a little bit lower. All right, so I'll probably have to erase this, but that's okay. All right, so I'm doing this outer red rectangle. Okay, so I know that the width of this is going to be 6, right? That's from here to here, so this is going to be 6. And then it includes this little space here, which is the same as the width, right, of the frame. But I don't just have it above it, I also have that same W length below it. So this is going to be 6 plus 2W, right? And actually, why don't I write it and set myself up to do an area method? 6 plus 2W. Okay. You could also do 2W plus 6. Remember that commutative property. Okay, so now for the length for the top part of it, right? I know that this top part includes the 8, right? It includes this section here. So that includes 8. And then it's got to include the 2 side pieces. So W over here and another W over on this side, right? That length is W also. So this is also plus another 2W. All right. So I know that that's a little complicated. Go back, try it on your own. This is a fairly common problem where it's either a picture frame or a garden or pool or something with a sidewalk that's the same length. All right. So now I'm just going to figure out what the heck this is in standard form. All right, so I have 6 times 8 is 48. 6 times 2W is 12W. 2W times 8 is 16W. And 2W times 2W is 4W squared. Okay. So I'm going to write this in standard form, meaning my W squared is first. 4W squared. All right. And then 16W plus 12W is 28W. And then I have 48. And that is equal to 24. Remember, 24 is the size of that entire frame, the entire thing that we're looking at. Okay, so here we go. I think, guys, I'm going to do factoring. All right. So remember, with factoring, this has got to be 0. So I can use that zero product property rule. All right. So let me erase that. And the first thing I want to do is actually subtract 24 on both sides. And I'm subtracting it from the 48 because those are like terms. So I've got 4W squared plus 28W plus 24 equals 0. Cool. All right. Now I'm going to get rid of the coefficient for W squared. So I'm going to divide everything by 4. And as you see, I'm out of room, so I'm going to move up here. All right, so 4W squared divided by 4 gives me W squared. 28 divided by 4 is 7, so 7W. And 24 divided by 4 is 6. And again, it's important that I've got a 0 because without that 0, I cannot do factoring and use my zero product property. All right. So I'm just using all the different spaces. All right. So if I am using area method to work backwards, first term goes in the first box. Last term goes in the last box. Okay. And I know that these W's have got to add or subtract to give me a positive 7W. All right. So let's see. W times W is W squared. And let me see. Let me see. 2 times 3 is 6. 2 times 3 is 6. So 2 times W is 2W. 3 times W is 3W. 3 plus 2 is 5. I need 7. So let me think again. All right, so 6. Oh, I think I know. 1 times 6. Let's see how that works. All right, so W times 1 is 1W, and 6 times W is 6W. 6W plus 1W, ding, ding, ding. That gives me 7W. All right, so my factors are W plus 1 and W plus 6. Okay. Remember, you can always put both of these guys in the calculator and you should get exactly identical parabolas and tables and everything else. Okay, so now I can use my zero product property. I can't use it with anything that's not equal to 0. And I'm going to set each of my factors equal to 0 and solve. So again, if you did a different method, then you should still get W equals -1 and W equals -6. Okay, so can this width be a -1? No, it cannot, right? So let me just put a different color. Nope, right? The width can't be negative. Now, can it be a -6? Uh-oh. Again, nope, sure cannot be a negative number. So in this problem, let me erase this again. There is actually no width that is possible, right? They're both negatives. And if you think about it, the original rectangle, the black rectangle, 6 times 8 is actually 48. So there's no way that you could make it bigger by putting a frame on it and have the maximum area be 24, right? You'd have to actually subtract from it. So even though mathematically W equals -6 and W equals a -1, mathematically spot on, perfect. If you got that, great. In this problem, neither of them work. No, no, no. No width is possible in this particular situation. Okay. And that's another thing about word problems. Not only do you have to solve it, but you have to make that judgment call of whether it is a good or a valid solution. All right. So, New Clarendon Park is undergoing renovations to its gardens. One garden was originally a square. All right. So, let me put a square here. And is being adjusted so that one side is doubled in length, while the other side is decreased by 24 meters. The new area is 25% larger than the old area. All right. So first, I'm going to pick a variable for the square, right? So let me just pick X. If you pick any other variable, that's fine as long as it's the same, right? What I know is originally I start out with a square. So my original area is X squared. Now this new one, and I'm not going to draw it perfectly to scale, right? Don't be silly. One side is doubled, right? That means twice the amount. So if it was X, now it's doubled. And the other one is decreased by 24 meters. So that means if I had X, then I'm going to take 24 meters away from it. All right. And I just wrote it like that because I didn't have room to write it all out on the same line. All right. So the new area is 25% larger than the old area. All right. So if the old area was X squared, I've got to add 25% of that. So if you are taking 25% of any term, you take the decimal value, 0.25, and multiply it by that original value. Okay, so the new area is not just the old area, but 25% of the old area. All right, so my equation here for the new one would be 2x times x minus 24. These are the new lengths, equals, now these are like terms, right? They're both x squares, and I've got an invisible 1. So 1 plus 0.25 would give me 1.25 x squared. All right, so we are actually running out of time, but I would encourage you to get everything to one side of the equal sign, and you can really do any of the methods that you would like. I would probably do quadratic formula, but keep it up to you. All right, so good job working on that. Finish that up on your own. Again, today's last day of the marking period, but not the semester. So if you struggled a little bit, maybe you didn't reach out to me and Mr. Q when you should have, and let's say you got below a 65. That doesn't mean you won't get the credit. It just means that now is a really good time to call us and be like, hey, what do I need to do? How can I make this up? You also have a test next week. So we are pretty much done with Unit 5. We're just going to test it next week and start on our very last unit of the entire school year. So good job, guys. And I will see you on Monday. Take this weekend off. Just rest, okay? And get ready for marking period 3.